Yeah, is that if you ever into that cable plugged into? Hold on, it's doing a thing. It's doing a thing. Boom. Yeah, there up there. Now you just mirror. Right? You gotta get on your main display. And you're good to go. Hello and welcome to IPPM at IETF 96. I think that will say that on the chair slides. I think, yeah, good. This is the IP Performance Metrics Working Group. It will be the IP Performance Metrics Working Group, so I hope you're in the right room. This is kind of a strange space this time around. I'm Brian Trammell. This is Bill Savani. We are co-chairs of the working group. Next slide. Do you have the little presenter thing? Can I actually do that? Does it work? Not working. Oh, okay. Yeah, we're going to have to do it this way. Yeah. All right. This is an IETF meeting. This is a working group meeting and an IETF meeting. The note well applies. If you have not seen this or read this, please do have a look at the slides. Anything that you say in this room is a contribution to the IETF. If you know about IPR on that, there are rules about how that has to be declared. So congratulations, we've done a bunch of stuff since the last meeting. We've published one RFC, 7799, active, passive, and everything in between. We've got one that's on the way to the IESG, the PDM option draft. So that was, I think, Bill pushed the button on that yesterday because I forgot to push the button. So that's an AD evaluation. So that's what Spencer's over there doing right now, is evaluating. We're done for now and waiting on metric registry. So this is the design of the metric registry, and then we have the initial registry document that we're going to be spending a fair amount of time on today. And we decided after we'd gone through working group last call and we're ready to go, do we want to push the button? Well, maybe we want to hold it in the working group just in case we figure out anything that we did wrong while we put the content in the registry. It's like, oh, we're going to fill this out. Oh, there's no field for this. Maybe we should add the field, and that's a lot easier to do if we haven't already published the RFC. There's a bunch of new stuff since the last meeting. Apologies on my part. This took a little bit longer than it should have because we ran some calls for adoption and then forgot we'd run calls for adoption and needed to follow up on the list. But we got all of these in now. There's, I'll do them in reverse order. There's draft IETF IPPM altmark, which used to be called P3M, which is the sort of the no-brainer, easy to standardize on our charter part of the P3M discussion we had in Buenos Aires. There's draft IETF IPPM TWAMP time format, which is, as I understand, basically ready to go. We might even start working group last call today because we've had a lot of revs on that as an individual draft already. And there's draft IETF 2330 IPv6, which I forget who I'm quoting here. This is part of our duty as a responsible standards organization to keep these things updated. And somebody noticed that the IPVM framework on top of which all of this sits doesn't actually support IPv6 20 years later. So we should go back and actually fix that. We have a process that we use in this working group that we've been running for a while, and I think it's running relatively well, that we try to reserve the face-to-face time to actually talk about work that's happening in the working group, and we use the mailing list to start discussions about things that might actually be adoptable. It might be a little bit hard to actually start from nothing to get to where you can actually have, a discussion, enough discussion on the list that there's enough interest that we can actually say, hey, it makes sense to bring this in on the main agenda. Anybody who wants some time to talk about new work that's focused at IPPM, who hasn't actually had a lot of discussion or a lot of interest on the list can come in and say, hey, please give us some time to talk about this. We reserve that at the end of the agenda. So any time after the main agenda, we give lightning talks. So 5 minutes, basically an ad for why you should, if you care about X, then you should read this draft and please talk on the list. But getting stuff on the list without a lightning talk, it's how do we get this to happen? You can announce new revisions on the list. You can also go and ask people to review and say, hey, would you go look at this draft? Like, so in person, go and say, or off list, say, you know, this seems to be interesting to you. Would you have a look at this? And please post to the list. So we use the list to determine where the interest of the working group is, because the work does happen on the list. And if we don't see a lot of traffic on the list, then we can't actually judge whether or not this is a thing that there's going to be enough interest in to bring onto the main agenda. We generally like to keep drafts as individual until they're relatively mature. It should be sort of a thought out idea, and then we'll consider them for adoption. It's not uncommon, like, so the TWAMP time format draft, I say we might start working group last call on this. This is the first meeting that we've actually had it on the working groups as a working group draft, but we've had enough discussion of it both in meetings and on the list that I think it's basically ready to go for that. We will consider mature individual drafts for adoption, but I think we're basically done for this year. So we're not going to run any calls for adoption today, and we're not going to run any calls for adoption in Seoul, because we have 3 big chunks of work that we're starting. So I think especially the P3M thing is stuff that I'd like to have the working group focused on, as well as finishing our original documents, getting model-based metrics out the door finally, and talking about getting the registry, which is what we're going to focus today's meeting on. So with that, here's the agenda. First, chair's prerogative, we've invited Ahmad Al-Dabah. Am I saying that halfway correctly? Close enough. From Ofcom and BEREC to talk about QoS measurement as relates to network neutrality and sort of the regulator use case for some of this measurement. And I personally thought this was really interesting. I met him and some of the other people from BEREC at a thing in Brussels in February. I personally think this is an interesting application of these metrics. It's like, you know, we work on the metric side of things, and having definitions that are actually nailed down enough that you can use them as a basis for standards, that you can use them as a basis for regulation. So I thought it would be interesting to talk about regulators and what they're looking at in terms of QoS measurement, aggregating QoS measurement, making judgments based on these. As users of these metrics, right? Are these metrics useful? What would be interesting for this QoS use case? And with that, we'll lead into a discussion of the contents of the initial registry. So Al Morton will be talking about the initial registry document, which is half placeholder, like half format placeholder and half, here are some things that we're pretty sure we want, but it's by no means complete yet. We should sort of have more of a discussion about what needs to go into that document here. And then quickly, TWAMP Yang, model-based metrics, 2330 IPv6. So TWAMP Yang, model-based metrics are the current working group drafts. We're going to move those closer to working group last call, and then the 3 new working group drafts. And then we have a queue for lightning talks, which we will almost certainly not get to the end of this queue, but this queue is ordered so that people who have never come and talked to us before, or people who are for new work that has not yet been discussed, is at the top of this queue. So we'll definitely get through the first 1 or 2, I think. And I hope to get through the first 3, but beyond the first 3, it seems optimistic. So with that, I'd like to invite up Ahmed to come talk about, and in the pink box, sorry that we couldn't find the meme, and I'll pass around the blue sheets.
Okay. Good afternoon, folks. Good afternoon. Okay. Hello. Hello. Hi. Yeah, we're getting there. We do have some slides somewhere.
Yeah, hang on.
They're over
try
there.
to bring them into something that
Oh,
more
that's,
thing, I hope.
you know what, Bill, we should switch sides of the table so that the presenter can see, or we should,
Okay.
just because he can't see from the other side.
Oh, good point. Yeah.
Like I said, the room's a little weird.
Okay.
Didn't work.
So while we're getting the logistics, my name is Ahmed. I work for the UK telecom regulator, but today I'm representing BEREC, and I'm here with my colleagues, Volker, whom some of you might have heard speak yesterday, but also Frode, who chairs the Net Neutrality Expert Working Group in BEREC. For those who don't know, BEREC is an organization that brings together all the European regulators under one umbrella, where we exchange expertise and experiences and run projects that have common interest. The greatest majority of the output is really around best practice for regulators and sort of not quite standards, but the way we think about the regulations and the laws and how we should practice them at our practitioner level.
Does it need to be turned on?
You looking good? Is there a switch on that?
I'm not seeing. I don't think there's any battery. I think the battery's dead. Oh, that makes sense.
Yeah, you turn it on. Yeah. Woohoo.
Ah, there you go.
Excellent. So basically covered the first bullet of my presentation. I'll talk about the network, the Net Neutrality Expert Work Group and the work we've been doing over the years. Then I'll talk about the program that we're going to be undertaking this year and next year, some of the challenges and some of the final remarks, and hopefully we can have a discussion about how the IETF might like to get involved. Covered what BEREC is. This is how we are structured. At the top, there's the board of directors, regulators, which all are head of organizations sit, and at the bottom, where the Net Neutrality Expert Working Group work is, and we all work in that yellow box. Over the years, you can see we've started in this area back in 2011, and sometimes towards the end of last year, September 2015, the new regulation on net neutrality was passed in the European Parliament. Around that time, we also published, we worked on a document which is about the feasibility of building a measurement system for net neutrality type of work, and also cost measurements. Currently, the guidelines, some of you might be familiar with what's happening there. Yesterday, I think, or the day before, when the consultation was sort of came to an end, and now my colleagues are sifting through all the comments they've received, and the guidelines will be finally published around end of August. The bit of work that I'll be talking about really is in the far box, which is about the next piece of work we'll be undertaking starting in September, which will be looking at some of the specifications for software and hardware and systems that we would need in order to take the guidelines and the regulations further into practice. When we think about the internet, so far we're more focused on the access networks as opposed to the bigger picture. That doesn't mean the core network or further upstream is of no relevance, but this is the access networks have a special regulatory interest, and we think of two kinds of services. One is this, what we call an internet access as a service. Internet access service as a whole. This is basically a pipe that delivers connectivity to the end user into the internet. And specialized services are those services which are provisioned by the access network provider, the operator. Things like telephony, things like IPTV, and the likes. Part of the internet access as a whole, we also think of in terms of individual applications. And the reason why we structure our thinking this way, that's because of the way the regulations are laid out, and some of the work that we've done in the past has defined our thinking along those lines. As I said, 2015, we finished the feasibility study, and the next is the toolkit that we'll be starting in September. And the tool that we look into, the toolkit, I should say, that we look into to develop, the aim is sort of to look at the methods for net neutrality cost measurements. So it's slightly different, perhaps, some of the focus that the internet community have been looking at over the years. As Brian said, we don't look at metrics for the sake of metrics, even though we do have a need for that in another part of our work. But the future will be very much focused on how we measure, how we use the metrics to develop some regulatory assessment of net neutrality and violations, if possible, that is. We'll also be looking to sort of pencil down the specifications for software that could be developed in the future or acquired, depending which way regulators want to go, in order to meet those requirements. And whatever work we do will go to the Board of Regulators for approval. So the monitoring aspects, which is now we are required to do by the new regulations, we have, like I said, it's going to be looking at two different aspects. One is the internet access as a whole, and we would require metrics to do that effectively, and also scrutinize the traffic down to the application or per application measurement. We also are thinking around the multi-NRA type of system where the NRAs, that's the National Regulatory Authorities, another word for regulators, the way we can collaborate amongst each other, either with a sort of a measurements, sort of some sort of a multi-NRA system, or otherwise, or it could be more around sort of harmonization of metrics and methods for measuring those metrics. We've always said that we want to adopt standards. We're not a standards body. That's why we are reaching out to the wider community. The IETF is one, for informing us on what standards that we should use and which one we should trust. I talked about the harmonization a little bit. One of the things that we regulators can do, and remember there are 28 states in Europe. There's a lot of variations between how different regulators measure the same metric, never mind the set of metrics. And even if you probably have noticed, if you, for example, use OCLA or another test measurement speed, so another measurement speed, speed measurement tool, you'd find they give you different answers to the same question, and that's something we regulators are trying to sort of get over and maybe hopefully reach a point where we can measure the same metric in a repeatable sort of way. In the past, we found that there wasn't really a best tool for one particular metric. Different tools behave differently, and this is feeding into our need for trust. And at the moment, some of these tools just can't trust to do the job for us. There's also a question on what is best practice. We can talk about measurement of speed, but where would the client have to be? Where would the server needs to be within the internet sort of architecture? There is the area of traffic management, which is now, of course, we are going to be looking at itself a much more, take a much more deeper interest in, let's say. When we looked at the tools that are available over the shelf, if you like, in the open source community, what we found was some of them weren't fit for our purpose. Others were giving unpredictable results. Others were predicting things that we knew did not exist in the network, say, for example, in a laboratory type of environment. There's also a question around, if you are undertaking such measurement, how long would you need to be monitoring for before you make a reasonable decision that could potentially stand in a court of law? Are we talking about millisecond resolution, second, minutes, hours, days, months? We don't know. Simply just don't know. Don't have that answer. Also, there's something about sampling here. Given that this new area of research is just springing out, how many, if we look into, say, for example, test a particular operator, how many samples, how many places in the network do we need to be looking at? So this is about sort of like geographic distribution, perhaps, geographic sampling, time sampling, all of these questions that keep coming up and we have no answers for at the moment, and hopefully perhaps some of the experts here can shed the light. We do appreciate that there are different approaches. There's the crowd-sourced approach, which is becoming very popular these days, probably because of the fact that it's very cheap. But we also appreciate that sometimes we do have a need for hardware, specialized probe-based testing, and we're not qualifying. Well, we think probably that the hardware base is much more trustworthy, but we're not also knocking down the crowdsourced software-based approach because of its ability to cast the clients further afield and on the sort of bigger scale. Some of the challenges that we are very much faced with when we do this kind of work within the regulatory world, privacy. That's number one. It comes up every time. System governance. If we start talking about sort of a multi-NRA system, where does the responsibility lies? How do we evolve the system? How do you operate it? Who holds the key? Because of the way we have been working historically, we believe the solution will be sort of along the lines of distributed systems. So each NRA will have their own independent measurement system in theory, but there's some interoperability between the different NRA system in order to exchange some measurements or some information that we regulators need amongst ourselves. Once we talk about that, then there's the problem of common data structures. You can't have interoperability at the information level without some sort of common data structures. And something of perhaps very much paramount important to us is system security and data integrity. We can't do measurements that subsequently could be manipulated. So over the years, we published a lot of our work has been published on our website. They're all accessible from our website. Either get the slides and click on them and it'll take you to the appropriate link, other than the feasibility study, which is an internal working document within BEREC. I guess this is really what we wanted to say here. We've come to this forum really to reach out to the, if you like, the technical community, the experts in this field, and we are seeking some sort of input, or we feel that the IETF should have a voice, should have an input, should have an opinion about how we could go forward in the future. We may not necessarily adopt it, but we probably would. I don't know. We'll have to see. And I'll leave the discussion open for everybody to contribute. Thank you very much.
Thank you, Ahmed. So we have a couple of minutes for questions, or we can go straight into the discussion of the initial registry.
Hi, Mike Ackerman. Good
Mike.
presentation, by the way. Is it fair to ask what level of information you collect from your various sources? Is it packet level? Is it application? What kind of level of detail are you looking for?
So we measure speed, we measure latency at the IETF.
I guess I'm looking for, like, how would you measure that?
That's the question we're asking here.
Oh, okay.
That's part of the question. That's a good point, actually, because different NRAs have been adopting different techniques for measurement. So one of our, if you like, aspirations is to converge and harmonize the regulators. But if you're going to harmonize and converge the regulators into a particular set of measurement metrics or methodologies, we need to know what those are. Yeah, with a reasonable certainty, if you like.
Hello, Luis Contreras from Telefónica. My question is, at the time of measurement services for content providers, that
Mic lines are closed.
that they,
No, it's good.
Sorry, can you start
Oh,
again?
go ahead. Yeah.
sorry, at the time of measurement services from content providers that at the end had the decision of delivering the content from different points in the network. So how do you can deal with this difference? Because probably one service provider could be served from one content provider in one way and to other service provider being served in a different way. So how far you can compare the results if you cannot pre-select the point from where the content is delivered
Sure.
to?
So this is why we possibly one of the reasons why I've been from a technical point of view, I've been focused on the access leg only. What you're talking about is perhaps further afield, you're looking at the sort of internet exchange points, the CDNs, and maybe as far as HQ in some cases. So the question is here is, should we be looking at normal live traffic, say, I don't know, some OTT video service, or should we be emulating these in some sort of way and inject it into the access network, say, for example, from a peering point or some internet exchange point? So that's also part of the question here. In the past, we've advocated that the service perhaps should be in some public exchange points, but if there is a better way, then we'll be open to it.
I'm Rüdiger Gab, Deutsche Telekom. Did you consider activities, how to detect background traffic, tampering with your measurement, and all of these kinds of errors?
So we have recognized that there's a potential for tampering with traffic and maybe some sort of operator fine tuning, but we don't know how to protect against that. Yeah. Again, very much open to suggestions, and that comes under our data and system security.
Joachim Fabini. So we've done some work in this area, RSC 7312.
Okay.
I'd just like to say that today's access networks are no longer copper wires from the behavioral point of view, and it's very easy to fine-tune such benchmarking and so on. So please, if you need some support, then just ask. My email is there.
So we've been working at layer 3, which is kind of like in theory blind to what access technology we suppose that. By all means, we do also recognize that perhaps, for example, mobile and wireless might be a special case, but that's part of the question that we approached at the beginning.
Yeah, that's exactly the question we tried to answer. It doesn't matter.
Yeah. Okay, thank you very much. So now I'll call up Al. Are you gonna?
I brought my own presentation.
Oh, okay, cool. And I realized that I actually. You got to stay in the pink box, Al.
Yeah.
I can't guarantee your safety. I would love to be. It's not that I won't guarantee your safety. I really can't. So I screwed up a little bit here. I was supposed to sit up at the front of the room and look really disappointed in y'all that nobody had volunteered to take notes, and then threatened to actually throw everybody out of the room until somebody takes notes. But now I've already started the meeting. I'm taking notes in the Etherpad, which is a really stupid idea for the chair to be doing. So now I'm going to do a little bit passive aggressive thing here. It'd be really nice if, no, this will just be straight up aggressive. It'd be really nice if somebody could, put their hand up and say, I will take notes for this session. Possibly somebody who is understands the sort of the area, knows the names, and doesn't have a document. It's already started in Etherpad. Excellent. Thank you very much. We have a backup for Barbara. Going once.
I'll back
Going
up.
twice. You'll back up for Barbara. Cool.
I had some stuff which I was going to volunteer to.
Thank you very much.
Yeah.
Barbara, there's already an agenda in there, so you can just go. Cool. Thank you.
Great.
Go Al.
Okay, I'll go. Okay, so this is 2 talks today. It's the registry and the initial contents. So I guess, let's see, one of these pointing at that does it. Yes. Yep. Awesome. Okay, so I included 3 slides here, which are a truly quick summary, and which I'm really going to go through in about 10 seconds each. So that's all the time on this one. But the problem is exactly what we phrased here. We have very flexible metric specifications. We realize that we have to nail them down a lot tighter. That's what the registry is all about doing. And all these other things are the reasons to do that. Really raising the bar on specifications will provide the comparability we believe. It's the best we can do as a standards body. Let's say that. Okay. So then here's the concept and format. Each registry entry is a row. Let's see, they're all going to be indexed by IDs and some other stuff there, the URLs. So the next slide shows the categories, and there's probably more time spent on this. So we have summary information, information on the metric definition, which includes a reference and a concept called fixed parameters. These are the input factors to the metric which are fixed in the registry. For example, the timeout, the amount of time you're going to wait for a lost packet and declare it lost, or it's within the delay window of receiving a packet. There's lots of other things that go in here too. They're all input factors which have been described in the parameters section of our metric definitions. So then jumping down to the next one, we also have runtime parameters. It makes sense to leave some of these open for runtime. The most obvious ones there are the source IP and the destination IP for packet measurements. But there are others that can be left open there too. It could be the stream characteristics, but they could be fixed. So there's always going to be interaction between runtime and fixed parameters. The obvious other things there are the reference method. We're going to continually point to specifications to support this. There's always two roles, typically, the source and the destination. When you're talking about telling a device to perform one of these measurements, you usually give it one of these two roles. It's the source or the destination, something like that. So then we specify one form of output. This is a full combinatorial specification of the metric. So for example, if you want mean delay, that's one metric entry. If you want the standard deviation, that's another one. It may have a lot of duplicate column entries, but it's now called out as a separate metric. Administrative info and comments. Any questions on that? Yes, come to the mic. Oh, did you have one? Oh, yeah. If you have one,
Yeah.
please, Ahmed.
Come to the mic and state your name for the record.
Yes, hello, it's Ahmed again. Again, is of my surname, by the way. One of the things that we are very much interested in is not just the metric, but also the methodology. I guess that's why you have the reference RFC.
Yeah.
But an important parameter for us is the precision of that particular metric. Let's put it this way. I personally am comfortable with an estimate of mean, which is not very accurate, but I need to know how inaccurate it is. You see what I mean? Yeah.
Okay, so the closest we can get to that, I think, is the resolution with which the system can report the result, because we're not specifying the actual systems. The precision is going to be dependent to great degree on the timing quality.
And
one-way delay, for example.
And all that information is to be captured in perhaps the RFC. Raising the risks or the issues that are associated with that particular measurement methodology.
So the RFCs do that. They talk at great length about clock-related issues and timing-related issues and so forth. And there is a section on reporting calibrations and things of that nature.
Okay.
So it sounds like you're looking for. This would be something that people implementing these metrics with a particular implementation and
Correct.
System would report what they believe
Correct.
is their nominal accuracy.
It's part of the calibration, perhaps. I did see somewhere the word calibration on your slide. I don't know. Maybe I missed it. But like I said, the principle is very simple for us.
Yeah.
Metric, how you measure it, and how good it is.
Yeah.
Or how inaccurate it is.
Right.
Whichever way you want to
that's an excellent feedback, and I think that we have to handle that in a way that doesn't. We can't specify. I don't think we want to specify a minimum accuracy here.
No.
I think
what
we want is for systems to be able to run a calibration test and report that along with the results.
Absolutely. And
so I think that I'm now hearing this as an output parameter, something like that. Yeah,
that's right.
Yeah.
And I lost the thought.
Sorry.
I guess. It's gone. If it comes back, I'll come back to the microphone.
So, Brian Trammell, Hatless. It occurs to me that it might be an input and it might also be a column on the method of measurement. So the method, it's not, in that case, it's not accuracy, it's tolerance. It's how, or do we don't really have resolution in there, but you could basically say this is the minimum resolution at which it doesn't actually matter if you're going to implement this.
Resolution comes as part of the output format. So
data format, all right, let me read that part of the document again on the output format, because I think that it's very subtle, the difference between this as a as a tolerance on the method
Mm,
versus the resolution of the output,
right.
right? But yeah, and then the output, like the achieved resolution, is part of the output, and to some extent that is a property of the data format if you're using a data format that allows you to express resolution. But it's an easy thing to get lost, and I think that's. Yeah. Sorry. So the idea is that Ahmed was asking about, well, what about resolution and precision? Oh, he was asking about accuracy and precision. Yes. Right. Right. Exactly. Yes. Right. Yes. Right. Right.
Yeah.
So he was asking about accuracy and precision and where do these show up? And I actually do think that there is a accuracy and precision associated with the output, of which resolution is a part,
Right.
but it's not necessarily the only part.
Right.
And there, I think it might also be a property of the method of measurement where it's essentially an inequality that says you must be able to get me at least millisecond level resolution, or this is not useful, right? So one of the reasons that we use this registry, we're defining this registry, is to say, here's how you should implement this, and here's how we can all agree on how to take these metrics and have a small list of things that we can have to compare. And one of the things that I think might be missing here is the achievable precision and the achievable accuracy.
Yeah,
It's both. Accuracy is more important. Yeah.
Okay.
This is why we left the registry format out of the IESG.
Yes,
Yeah.
that's right. That's right. No, excellent points, and thanks for additional clarifications, Brian and Greg.
Marjo, just so to follow up on that question, I was actually thinking about where it's not necessarily accuracy, but it's variation. So in that context, I think Ahmed, was referring to the summarizing function, right? So summarizing function for the mean. What's the distribution? I wanted also to ask about sampling distribution. What exactly does it mean? Like what does it refer to exactly?
That's our opening for passive measurement. So you can have traffic filters, which you set in, and that enables you right from the start to kind of narrow in on the stream of packets you like to observe.
So it's
then you may not observe every packet in that stream because there just may be too darn many of them.
Yeah, of course. Yeah. Population, let's say so. In this context, I was actually thinking about the statistical information. And I'm not sure how that can be captured, but it might be important. So for calibration purposes, to actually see if the measurement is relevant, right? We have been discussing this in BMW as well.
So I think the combination of various summary statistics will help you determine the confidence in the thing that you've measured. Ultimately, if you've got a strange distribution there that kind of befuddles the classic metrics, the bimodal distribution is a great example. There, you've got to then look at something more complicated, and that's where if you've got that situation, the strength of having a private registry or a set of parameters that are fully runtime really helps you to narrow down and to collect all the raw results. For example, that was one of the openings we wanted to leave, is that you can have a registered metric that you measure, and what you get back is every individual result for every packet which flies through the network, right? So and by the way, this is what IPPM RFCs require. They actually want every singleton. Not everybody provides this, but if you look at the RFCs, that's what they want. They talk about pairs, time, measurement. So this should be able to do that as well. It's just that at one point we had raw statistics in there, or not statistics, raw individual results, and it was mixed with, it was 2 outputs instead of 1. So quickly we wiped out the raw one, and so that's another input, in fact, that we should at least include some of these cases that are raw output, the individual singletons.
I guess I was trying to clarify if that's saved somehow in the registry, like that information. Of course, you have the referred RFC, but is there a possibility for having multiple functions, like instead of just mean, like have median, maybe first percentile, 99th percentile?
Oh yeah, oh yeah.
So that's
in fact,
possible, right?
when we get to the naming, you'll see some of those things.
Sure.
So you're
Okay, I was going up. Yeah. Okay, thank you.
yeah. All right. So you can sit down. Let's get to Greg here, and then we can maybe move to slide 5.
Thank you. Greg Mirsky. Back to the question of defining or determining precision of the measurement method. That's actually a question to you as a co-chair of the benchmarking working group. Would it be something that a benchmarking working group will work on?
Well, I think that's out of scope for this topic. But
Yeah, that sounds like an excellent question for BMWG.
yeah, and so our meeting's tomorrow. I'm sorry about that, Greg.
No.
The short answer is yes, it's a repeatability for us. But RFC 2330 describes these terms: precision, resolution. Look at the framework. That's where the answers are. I didn't particularly like all the terms they chose, but those are the ones we're living with. All right. Yeah. Okay. Looks like we moved on here. So, in talking about the registry draft updates, this is what's actually happened to the registry since we talked about it. We've now referring to the definitions in RFC 7799 for active, passive, and hybrid. So now you can name those as part of the naming scheme. We've definitely got the URI column in there, and it includes a URL to a human readable entry. Let's see, we're still working on the details of this with IANA. In fact, when I saw Michelle Cotton just as the meeting was starting, she went, "Al," and then realized she hadn't sent me any comments on this draft. And so there was an immediate apology, but they realized that this is a big nut to crack that's coming their way, and early review is going to be valuable. They certainly appreciate that. So we're going to get IANA feedback on this as well. That's another reason to hold it up from publication. So let's see. So we added hybrid as a naming element as well. So that kind of falls into the rest of it there. It's kind of a little bit of a duplication, but that's okay. I got a job for you, Spencer. All right, so here's not yet. Hold on. Boom. So way back in section 10, it was like the security section. When we've talked about private registries, and in talking about them, we've encouraged folks to use the same registry schema that we're using here, so that if someday you want to take a metric out of your private registry and pull it into the main registry or the IANA registry, it simplifies that process, right? And also it encourages you to look at the previous standardized registry entries to get an idea of the kind of detail that's going to be necessary in order to accomplish this. So, but the initial point here is, do we insert private, PRIV, as a prefix to the total name? And you probably want to see what the names look like before deciding this. So, but I think that's a reasonable thing to do, and it means that you can pull that prefix off, and ultimately, if you've done a good job with specification, you can move your registry right into the IANA registry at some point in the future. So. Okay, so then we had this naming scheme, and it started out with the kind of the method, which was active or passive. Now that would be hybrid, the layers, and all sorts of stuff. I'm going to skip over this because that's not what we're using anymore. Spencer? Hit the, perfect, you did great. So here's the naming scheme. I'm naming it the Buenos Aires scheme because that's where we came up with it. And so it starts out with a metric type, a metric method, and then a number of subtypes for method, of which there can be a large number if you want to truly go into lots of details here in the name. So then the specification that describes the metric, the clarification there is that's the RFC where this where this particular registry entry is defined. It's not the long list of RFCs that provide the references which would appear in the format, which I just showed you a few slides ago. So then we have the units of measurement and the output format, which is both the metric and the resolution and all sorts of things related to that. So then we have metric types, round trip delay, one-way PDV. There are going to be more of these. There's no question about that. Active, passive, hybrid type 1. If you look in that RFC, there are different types of hybrid. Type 2 and spatial metrics is another. So the subtypes, include the protocol layers. They include the sampling, basically the stream characteristics of Poisson or periodic. And you can have, the RC that I mentioned there. The units are, seconds, ratio, and percent. Those are the names we've come up with so far. Then here's from Marius. Here's all the statistics that we've considered and included so far. Now, of course, there can be more, and that's why maybe we'll have additional. I mean, IANA may come back and say we want you guys to have a sub registry for each one of these categories, and let's let them say that if they want it. I think it maybe in the end it may not be a bad idea. So please, Marius.
Yeah, Marius Georgescu. So yeah, from my perspective, it looks good. Yeah. Singleton, minimum, maximum, mean, median, standard deviation. I don't know about bimodal distributions, but I think this should be enough essentially to understand at least if there's a problem with the distribution. Yeah.
All right. Thanks. All right. So then those are basically the candidates. Yeah. Okay. Please, Spencer. Okay. So now we're trying out the Buenos Aires names. And in the initial contents draft, we have 5 or 6 metrics there, and so this is what they look like for a round trip delay specification, which is an active measurement, which is UDP, which uses Poisson distribution. It's going to have an RFC that specifies it. It comes out in units of seconds, and why? Because it's the 95th percentile of the distribution. All right. So, comment.
This is probably diving, Brian Trammell, Atlas. It's probably driving way down a rabbit hole, but you're showing strings with underscores in them, so you started it.
Yeah.
Having worked on systems kind of like this in the past, one of the things that people like doing is having code that writes code that writes code. That writes code. So having identifiers that won't parse in most programming language, as identifiers as in most programming languages might cause problems. So that percent sign in there might be but
okay.
Because but I'm making a second point there as well. The hidden point is that these variable names are so long that no one will ever use them unless they're automatically generated. Right? These are not very, I mean, like in terms of names for things, these are not extremely useful for humans. They're more useful for humans than here's a paragraph of text and all of the information in the registry. But yeah, these look like things that then you're going to have a string and you're going to do a string comparison somewhere. Or you're going to have code that gets automatically generated somewhere, and that's probably fine. But in the choice of naming things this way, and I don't think there's any other thing we can do. I think we should just realize that we're now in an architecture where everything is automated. That's cool. I don't like writing code, but
I like it that the names feel hierarchical. Huh? They feel hierarchical in the sense you can keep adding sublayers, correct?
Yeah. And you said you like that?
I like that. That's actually an important property that you want to capture the right amount of. And ASN1 goes too far, and not having any is not far enough. And this is sort of a nice place in between.
Okay. That supportive comment came from Matt Mathis. All right. Thank you. But Brian, just to, before you jump in, Andrew, please, you're suggesting we should get rid of the underscores, or replace them with something else.
So the underscores are actually much better than dots, because we did this with mplane and we put dots in, and they're like, 1, it looks like a domain name.
Yeah.
And 2, you can't put dots in, like in C. If you're generating code in C, then you have to have a thing that translates the dots to underscores. So underscores are fine.
Okay.
It's the percent sign in there that might cause problem with string escaping.
Got it. The first words you said were about an underscore, and I thought maybe I missed something there. Sorry. Good, thanks. Andrew.
Andrew McGregor, are they hierarchical or are they label sets a la Prometheus or Logmon?
I missed the last part of that.
In the style of monitoring systems like Prometheus or Google's Borg1. In other words, the label set is a bunch of labels attached to it that are not inherently ordered, unlike a hierarchical system. So it's a multi-map rather than a tree.
Not inherently ordered. Some parts of it are
So there should be a
ordered.
syntactic distinction between the parts that are ordered and the parts that are not.
Sorry, I'm lost.
So Andrew, I think the only part that is inherently unordered is the subtype methods, of which there can be some variable number. And then, you might have, instead of, this could have been titled Poisson UDP instead of UDP Poisson, that kind of thing.
And so there should be a syntactic difference to indicate that. I don't know how you do that.
Oh, great. Throw the problem down.
So
Well, go home and think about it, all right? You have a long plane ride.
we have a remote speaker in the virtual queue, Inky, or I forget the names of the ghosts over there. So this is Ignacio Alvarez Hamlin. I'm going to push the button and he should be able to speak. Go ahead.
Hi. I would like to ask, because I see there is UDP Poisson and UDP payload. It seems that UDP modifies Poisson and UDP modifies payload. I mean, this should be some kind of unified field. I mean, it's not clear if you use always underscore to separate different fields, or in this case, these fields are connected. You know.
Yeah. In fact, Ignacio, what I'm suddenly realizing here is I grabbed these. I guess I grabbed these names, and I accidentally repeated UDP there, so that shouldn't have happened. And payload and the number which follows, I'm sort of thinking that should have been one term. And actually, after I submitted the draft, I realized I should probably put a big B behind the payload size, which indicates this is in bytes, not bits. So I appreciate that. That's a great comment. It's something I had partially intended to fix, but had to live with what I submitted. Thanks.
Yeah.
Okay. Thank you.
Thank you.
How are we doing on time?
Not great, but
okay, 1 minute. Look. I think there's lots of intent to provide input on the naming. So let's continue to work that on the list or in the hallways here in Berlin. And let's quickly move on to something else, which is the initial registry entries. Thank you, Spencer. And one more time. Oh, this is working great. So I'm seeking feedback on the current. Yeah. Yeah, I will. I'll go right there, right now. Let's see. We're still seeking feedback on the current contents. What else we could add in terms of metrics? And in fact, you don't have to do this, but back to here. I mean, this is what we've currently got in there. Notice a few things are missing here, right? One is loss. We definitely need loss in there. Oh, that's right. Okay, so section 4 and 5 have been updated with the kind of the new expanded format with very careful naming and so forth. And then and we added IPv6 examples because Fred Baker sent a bot at all of us in Buenos Aires to remind us to do that. So I think here's what we need to add. Loss, I mentioned. Trace route. We're going to talk about that. In fact, Joachim and I have talked about it a bit this week, and Ignacio is going to participate in those discussions when we can get him on the line. We need to nail that down, I think. It came up in a LMAP comment that ICMP ping, that people want that in there. Linda Dunbar, and Jürgen suggested, this might be a registry entry, and so we have to follow up on that. Tiziano Ionta had some good comments, but it was mostly about, what's really fixed or runtime here, and if I'm not doing it this way, do I have to change? And in general, the answer is it's an opportunity for the private registries. So thanks for that. All right, so any new metrics other than the ones I mentioned? I don't see anybody running the mic. So next step, we got to discuss and close the open issues, many of which were raised today. Naming, we're still working on. Al's got to update sections greater than 5 with the sort of the expanded registry entries that pick up the formats that we've sort of agreed on here. And I think that does it. Thank you very much, everyone.
Thank you. So I'm actually going to say this without taking my hat off. I think that there's one big giant one missing, which actually, so when I went and gave my talk, which is how I met all of the Barrett guys, about what we haven't done yet. And the big one that everyone cares about that we haven't done yet is bulk transfer capacity.
Yeah.
Speed. And it would be interesting to see, since I'm sure that's where a lot of your demand on just sort of like, when you say QoS, it's just straight up undifferentiated, what's the speed, how tests for that, like it's not the speed X minus speed Y or speed X over speed Y, but just speed X and speed Y, the speed given this test or these test conditions could be, with model-based metrics.
Yeah.
Could be expressed using this. I think it should be one of the ones in the initial registry.
So the answer is, before Matt gets to this, I think the answer is describing the stream.
Yep.
And then its loss and delay.
Right.
Round trip time.
Yeah.
Matt
Mathis, author on model-based metrics. We'll be talking about in a second. Actually, model-based metrics have another parameter that it's a two-dimensional metric. And this is actually something that other registries have fallen down on. And I will take it as an action item to think about specifically how to represent model-based metrics in this framework.
We'll do that together.
Excellent. Cool.
Sounds like fun.
Yes.
Thanks.
Right.
All right. So next is Kostas, who has more than 3 minutes.
We will find out.
Okay. All right.
15, but we're running late. But
So I'm really sorry because I missed Buenos Aires, but what can you do? Okay, so who has read the draft? Please raise your hand. Okay, that looks promising. So these are the two figures. We probably may need them for the discussion. I think for those who have been familiar with TWAMP, you don't really need them. But I want to emphasize that there are, in figure 1, 4 logical entities based on what the original TWAMP document describes there. They are a little bit redrawn compared to the original figure, but that's about it. We had a major change in this version, and that is basically that we got an extensive young doctors review, which highlighted a couple of things that had to do with what goes into the young module definition, what goes in the UML figures we had, and also in the description that we had in section 4. And some things actually proved that they were a little bit contradictory, as you will see, and Mah has replied to that review, one of the co-authors, obviously. And one of the things was that, in Yang, it appeared like a mast, while we had a should, and so on. To get out of this problem, we decided within the author group to, and based on his suggestion, of course, the Yang doctor, to move all the specification effectively in the Yang module. Now, you can click on that revised and you will see that there was a lot of blocks of code moving around. There was also some optimization fixes and so on in the Yang module per se, and also some renaming of things. I think now it looks definitely more elegant, at least on the young tree. And I think it's quite more clear. That said, this basically implies that a lot of the protocol stuff that was in section 3 and 4, actually now they have been into the young module. So we think that it's still a very good idea to keep the UML diagrams, although there is a repetition because you have the young 3, you have the young module. However, for people who are coming from a protocol perspective, T1 perspective, and they're familiar with that, we find that that's probably much easier to read. More people are familiar with UML diagrams than they are with young tree. So maybe in 10 years that will be different, but that's about it. So all of this meant significant editing on the document here and there to try to, get rid of any kind of duplication and so on. So consistency checks and stuff. And that meant also that sections 3 and 4, again, based on the review we got, we are considerably shorter now. And as I said, the authoritative specification of the T1 data model is actually in section 5 now. I hope that. I think we got the same comment from Fred Baker about adding IPv6. So we complied with that, so that you can see also in the diff. And now we have security considerations, sections filled in. So maybe some security experts may want to have a look at that as well. And we had a little bit of a discussion also from a young person's perspective. In this case, was a doctor. They perceive that the operational commands is part and parcel if you're going to define the young data model. So in that sense, the comment was that maybe the value of this is diminished if you don't have operational commands. Our feeling is that basically, if that's not part of the base protocol, we cannot really have a data model for that. So if we go and we define the operational commands and so on, then obviously we can do that in Young as well. Now, if for those who didn't read the draft, you will remember that in figure 1, there are 2 unlabeled links, and that's on purpose. And that's basically where you would have the operational commands and so on. So for this purpose, we did have a little bit more text in the main document and a short, Appendix B, I think it is, that gives a little bit more background into that. So I don't know, does anybody have a strong feeling about operational commands for this?
Greg Mirsky, Ericsson. Yes, I think that operational commands for T1 test model are essential. Mm-hmm. Actually, I do have the question comment on reference model because the T1 control is an optional to control the T1 test protocol. When we are using data model.
Where is that in 5357?
Yeah.
The fact that it's optional, where is that in 5357?
It's in 4656 in OWAMP.
I think there may be other readers that have a different opinion about that.
Yeah. But again, my understanding is that T1 control and T1 test are 2 different standards, and there could be a different control plane for the T1 test. So in my view, the data model does provide this control plane for the T1 test, and it should be capable of being used without T1 control data model.
Well, actually, this is indeed the case. So if you go through the Young module, each one of the entities that you see here, control client, session sender on the one hand, and server and session reflector, actually can be on themselves, on alone. So I could be a, for example, session reflector vendor only. I can just sell people reflectors, nothing else. Once this thing becomes an RFC, if I go to my customer and I say that this is my session reflector, which is RFC XYZ compliant, it's done. I'm not selling them the rest. I'm just telling them that my session reflector product, container, software, whatever it is, actually supports this Yang module. And there is nothing in the RFC that says that for anybody to be compliant with this, they need to support all 4 logical entities.
Well, the way I read the data model is that it has, in a sender and reflector, it has a dependency on information that being negotiated in control. So it's not explicitly configured onto reflector or sender.
Right. So I would say you read this version 01.
Yeah.
So I would say that I don't agree, but we could bring it on the mailing list if you want.
Okay.
I mean, specific text, what you want, and we'll take it from there, I guess. Right. And I think I'm on time, huh? Hey, you see, you conditioned me to 3-minute talks.
Yeah.
I'm done in 7, including discussion. So way forward, I think the document has benefited a lot from your reviews. We would definitely like people to have a look at the Yang module and so on. Obviously, it passes validation and so on, but checking against your implementations would be interesting, and that would give us some feedback back to the discussion we were having before the session started. And I think probably after the changes, hopefully, given the amount of bandwidth that young doctors have these days, we will be able to get a second round review, let's say. There was, for example, an issue about how you formulate specific things, et cetera, and it would be good to say, yeah, good, we're done with that. And I think hopefully this could happen in a reasonable amount of time for definition of that. And obviously more review from the working group. So T1 people, so people who have been working in measurements and they're not familiar with Yang should be able to read this document and understand what we're talking about. And that kind of review, I think, has not happened yet. So it would be really nice if we can get 3-4 volunteers in this meeting who could send back a paragraph or something. I read it, I skimmed through it, and it's good, or that is confusing, or something like that. So we can cover the Yang, base, and we can cover the T1 people base.
Can I see a show of hands? How many T1 people are in the room? Okay, thank you for volunteering to review. So that was 4.
Right. Yeah.
So you all
I
have to
think
review.
Al was probably one of them. So
Yeah.
So that would be really nice. And so in principle, also I don't want to play chair here, but we are behind schedule. I think we originally wanted to get done by Buenos Aires. So I hope we're done for Korea.
Wasn't it? Where did that?
Was it the milestone for March? I think.
Yeah, it was a milestone for April.
Yeah, right.
So I'm editing the milestone right now so that Spencer can approve. I know you don't have to approve changes to we're late.
Right. So I think November then, right?
November. It's when. Yeah. Okay. Everything else is November. So hey, why not? Yep.
Okay. Sorry for the delay, but
Not a problem. We've been later on other stuff.
Any other questions?
No.
Thank
cool.
you.
And with that, model-based metrics.
Roger's turn doesn't need to look at this one.
That works.
And I might pull the microphone. How close do I need to be? Okay, model-based metrics.
That's that tile slide. And I don't know why it's
Oh, okay.
coming up blank.
First slide.
Eventually, go to the next slide.
Okay. So I'm Matt Mathis. I've been working on model-based metrics for far too long, mostly because I've got a day job that doesn't always let this in. And I've missed a couple IETFs here. I want to talk today about where we are and what we need to do. I think the document is really ready to go. It's been working group last called, I think actually through two twices, and gotten pushback on language. And we've been spending a lot of time trying to straighten out the language. And so I'm just gonna leave that there. Then I'm gonna get to that in the end. And I'm going to talk about some concepts in model-based metrics to try and tie it together and motivate people why we're interested in, why I think this is the right answer for a whole lot of questions. Next slide. That's what I didn't get. Okay. So the idea behind model-based metrics is to derive metrics for measuring the IP layer, the network layer, on the basis of performance targets at the transport layer or at higher layers. And the idea is that you would like to provide performance guarantees to users at fairly high layers, or we were at the time we started this, we were thinking about entirely in terms of bulk transport. But the thing that the ISPs can measure is just IP performance. And they would like to have a way of tying IP performance to transport performance, because they don't want to be on the hook for parts of the system that they don't own. So you want to have IP tests that evaluate sort of the obvious things, the basic raw capacity and the loss ratio, the amount of packet loss you get. And you want to use then authentic traffic patterns, which the transport protocol is likely to generate, to try and measure each of the subpaths under test. And the goal is to construct suites of tests that have the property that if all of the IP tests pass for all of the sections of the end-to-end path, you believe that the transport performance will meet the performance objectives. And if any of the tests fail, that there will be some users for which they will fail. Not necessarily all of the users, but some of the users for which they will fail. So here's a modeling framework. This is a non-ASCII art version of the diagram in the document. The point is you start at the top with a target transport performance for bulk transport capacity. The primary parameter is target data rate. You also turn out to care about what the intended round trip time is, the maximum round trip time that you need to support because of some details I'll get into later, and also the MTU, the maximum transmission unit. And you use some models to predict what sort of the span of traffic patterns that transport could generate for those parameters. And the delivery evaluation, you want to estimate how good the delivery has to be in order for the transport to meet that specification. So let me give you two specific points here. The traffic tends to be bursty for self-clock protocols. It tends to be bursty on the time scale determined by the target round trip time. So if I'm actually running on a 10 millisecond path, I'm likely to see a 10 millisecond structure in the burst, and that actually matters to the queuing. The delivery evaluation, the one used in the document, is actually the 1/√P TCP performance model. It has the property that the threshold for the loss rate goes as the square of the round trip time. So this test gets harder as you make the path longer, and that is actually something that we observe in the real world, that it's harder to get transport to run over longer paths. Let me say something else that's really important about this. To the extent that you can construct the test such that the subpath doesn't influence the traffic and doesn't influence the statistics, it doesn't matter exactly where you source and sync the traffic, the test traffic. The goal is to have a property here called location independence, which other metrics don't generally have. Other internet metrics fail at this. If I have a path that has a flaw in it, that has some sort of weak link in it or something, it should be observable for any stream that goes through that path, even if they're different links, even if they're from different test sources, even if either the ISP measures the link itself or an external observer measures the link from a longer path that includes the link. This is the goal. So The concept of model-based metrics actually is not specifically tied to bulk transport capacity. Bulk transport capacity is the one that's the most interesting because of some special properties I'll get to in a second. The first questions, there's a long list of metrics inside of the document, but they sort of fall into three buckets. First of all, whether or not the pipe is big enough. That's kind of an obvious one. And whether or not it has a low enough background loss rate. One of the important details that I will talk about on the next slide is it's important that you suppress the self-inflicted congestion caused by throughput maximizing behavior in TCP by congestion control. The next group of tests are queuing tests. This is basically whether or not you have enough buffering to deal with the burstiness in the data. And then finally, there's a bunch of things that are called engineering tests, which refer to whether or not the whether or not the dynamics of the network plays nicely with the control systems in TCP. And you can actually meet the first two groups and then have protocol devices that fail. One that's been in the news lately in the IETF is buffer bloat, which is the state where the network is not sending adequate signals to the transport to slow it down appropriately. It doesn't hurt your own capacity, but it screws everybody else on the channel. One of the historical ones is a phenomenon called capture effect that was first discovered in Ethernet. If you have a link which is half duplex, which you do channel allocation by draining all of the packets waiting in one direction and then reversing the channel and draining all the packets in another direction. If you run a self-clock protocol on a link like this, it turns out to revert to stop and wait. And you burn half the performance because of the interaction between the channel allocation and the transport protocol. Anyhow, there's a bunch of tests to look for things that the network sort of has to not do in order for the self-clock protocols using TCP style congestion control to be able to fill the network. They're not really specific to TCP, and they're actually not very even specific to bulk. Many of them are not specific to bulk transport. So, self-inflicted congestion. The reason bulk transport capacity is so complicated is because, in fact, it's a dynamic equilibrium problem. It's very much like chemistry, a chemistry problem or something where you have multiple state variables which are interacting very, very strongly, and as a result, all of the states are very strongly coupled to all of the other states, and the entire system behavior depends on parts that are out of scope, that are out of control. And furthermore, because of the sort of circular dependencies between all the parameters. So for instance, the data rate is determined by the loss rate, and the loss rate is determined by the queue depth, and the queue depth is determined by the window size, and the window size is determined by the loss rate. So you have this long loop of dependencies with very complicated behaviors for each piece. Measurements done in a system like that aren't predictive for other environments. And so they're not comparable. They're not really metrics. They don't tell you much about the system. What they tell you about is the number that you got for a particular measurement. If you suppress congestion control, you make the dependencies all open loop. None of this, all the circles go away, and then you can actually get independent measures of parameters like loss rate. That doesn't depend on the fact that TCP is using loss to measure the network. Let's see, and the goal is to make it predictive. So let me talk a little bit about the importance of location to dependence. One of the properties, and this will become intuitive once you see the aha. If I measure with a TCP protocol, a basic TCP protocol, the performance from MP1 to MP2, it does not predict the performance for any other pair of connections. We all know this today because it happens all the time. We don't do these kinds of tests because it happens all the time. The point with bulk transport capacity is the metrics you get from bulk transport capacity are predictive for other pairs of measurement points. And those metrics then determine a bound on what the TCP performance would be over the same path. So please read the draft. The source is actually in GitHub now, and I'm open for questions.
So who's read the most recent copy of this one? This is actually, it came in relatively short on the deadline.
It came in an hour before the deadline.
An hour before the deadline. Relatively short. All seven. Excellent.
07.
Oh, 07. Oh, okay. And the diffs. Okay. Yep.
Yeah.
Others who've read, I have not yet read the most recent one. I read, what was the second one? We did the second WGLC, it was 05, right? So you think it's done?
I think it's done.
I think it's ready to do a working group last call.
Al, do you think it's done?
Yeah. It's done enough for other people to read and understand it.
Okay.
Yeah.
We have Ignacio in the queue, so I'm going to bring him in. Red button.
Hi again. I would like to ask, because it's a very interesting approach to measure the bulk capacity, but my question is, there are new technologies now, for instance, multiple TCP path and this kind of solution that uses multiple paths to transfer some kind of traffic. And how do you expect to apply these results of your measurements to this kind of technologies? Thank you.
I actually hadn't thought about multipath TCP. I have for a long time been thinking about the issue that one of the things that we're running into here is that standard TCP congestion control is running out of scale at the scale that we're using it today in the public internet. I used to work at a supercomputing center, and 10 years ago we ran into the environment. You can't really get TCP to run a gigabit on a long path on sort of off-the-shelf stuff. You gotta do a lot of handcrafting stuff. And we're now in environments where people would like to market gigabit links, and guess what? The problem is TCP, not, I should say the problem is standard congestion control, not either TCP itself or the network.
And one more answer, Ignacio, Al Morton.
Okay.
Multipath TCP has several separate paths that you can identify. So you could potentially apply this to the paths with the different technologies, with the different RTTs, identify their bottlenecks, and perform this test separately either in parallel or in series to estimate the performance of each of the members of the multipath set.
Right. What it would entail is putting a slightly different model in for the model here.
Okay. Thank you.
And I'll take my hat off real quick and point out that with respect to MPTCP, they're also talking about how these things are coupled, right? So any change in how MPTCP does that changes the model as well, but that's fine. I mean, because the basic metrics that you're doing the measurements on don't change.
Yeah, the really key point is to eliminate these circular dependencies, these loop dependencies.
Yeah.
Fine.
Cool. Thank
Going
you.
once. Thank you.
All right, so we have one person who's read the most recent, I would say, actually, we're just, in order to motivate it, we're gonna go ahead and kick off a working group last call after, we'll say it starts right now. The working group last call on model, the nth working group last call on model-based metrics 07 starts now. We'll follow that up on the list, and we'll have it end, we'll run it for a month just because people take vacation.
And I actually already have 3 nits in the draft, but they don't even rise to the level of rolling a draft. They're typographical errors.
All right. So I'll also put the GitHub link for people who are so inclined in the working group last call mail so people who actually want to do that via pull request can do that as well. All right, thank you very much. Joaquin.
Hi. Yes, good afternoon. So this is a work that must be done. It's a patch to Ippm RFC 2330. Yes, next slide, please. So probably it's known by now. It wasn't known a few months ago, so exactly 1 year ago, as part of the general review of RFC 2679 bis, Brian Carpenter raised the question that there is no IP version 6 support in RFC 2330. So basically all of our metrics that rely on IP version 6 support currently do not have any support. a small sentence in RFC 2330 says that the version field is 4. Later we will expand, and later is now. So the solution that was adopted was to outsource this the IP version 6 support to an own document, because otherwise you would have had the need to change any document and augment any document, any metric that is released. So next slide, please. High-level scope of this of this draft is to highlight these aspects that are specific to IP version 6. There are basically 2 items. It's the type P of packets, a specific type that is used for testing, and the standard font packet. Yes, I'll skip over the technical details. Next slide, please. As about the status, we have presented the draft at Yokohama and remotely at Buenos Aires. There's an unanimous consensus that the IP version 6 support must be there. We need it. And it has been adopted as working group item in June this year. We have changed just the document title. I hope that Brian is happy with the new one. And also the document name. And yes, next slide, please. Yes, after submitting the last version, we received input from Fred Baker, and thank you very much indeed for this feedback, because it's valuable. Yes, it's a grammar issue that in fact formed is a verb and standard is an adverb, and it should read standardly formed, but yeah, I'm inclined to tend towards standard form for being consistent with the RFC 2330. Anyhow, we'll discuss this on the list. So there was some issues about TTL hop limit, that we can use it also as a metric and as an indicator, because, for instance, in neighbor discovery, we have the TTL must be 255, so we cannot do neighborhood discovery outside the network segment, meaning that this might be a relevant test. We should use it too. So with IP version 6, it becomes relevant. Fragmentation in IP version 4, the RFC 2330 discourages and prohibits fragmentation. So a valid packet must not be fragmented. With IP version 6, there are cases when it is relevant to have a fragmented and to consider a fragmented packet, large video frames, for instance. We will discuss this and include it in the next version of the draft. Then also header compression, we have treated it now. It's suggested to move it to an own separate section, because IP version 6 headers and IP version 6 compressed headers are 2 separate items. And yes, and the main issue that we have with the current version of the draft is the extension header treatment in intermediate nodes. Right now, there's a heavy discussion in 6man and V6 ops on the treatment of extension headers, whether intermediate nodes can read the extension headers, whether they can change them. As far as I know, the tendency goes toward prohibiting such access, but we are looking for a solution. We will not invent our own solution. We will try to get compatible to the solution that is found in these working groups and align with them. Next slide, please. So yes, and one more, Marius Georgescu gave some feedback. Thank you. It was too late to integrate it on the slide. So on transition, IP version 4, IP version 6 transition methods and net issues to include them. Yes, so timeline, we depend on other work. So we adopted a conservative deadline, Prague, in about a year to be ready. And yes, we're ready for questions.
Yeah, so Marius Georgescu, I wanted to know that, first of all, it was my first question in the mailing list as well. Is or are transition technologies considered by the draft? Are they in the scope?
We have a small paragraph on this. that with the type P, that it might change along the path and so on. It basically covers, but it could be made much more explicit. You're right. So
Yeah, I think it only talks about not, and okay, not is one of the ways to do the transition, but there are many other ways, and maybe some more details on that. And also on the overhead, I was thinking that it might be necessary to specify that somehow.
It changes the type P. Yes. So basically, it's all related to type P. And if you do white box measurements, then of course it's relevant. If you do black box measurements, then it's kind of hidden. So
yeah,
we need to find
matter,
a trade-off here. But we will definitely approach you also with respect to this one, and we'll integrate it.
Yeah, thank you.
Thank you.
All right, thanks a lot. So just logistically, primarily the work now is watching what happens in 6-man, or I mean, there's a bit more to do, but
First
the bulk of this time.
No,
is,
first integrating the comments,
Yeah.
all comments of Fred, and
Right.
and seeking a compromise with
Okay.
Marius, and afterwards, then watching what
waiting.
happens.
So shall we put you back on with another 5 minutes in Seoul?
Yes,
or
please.
do we
Yes,
just, okay,
yes,
cool.
There will be a new version.
Okay,
until
good.
then, yeah.
Yep.
Matt Mathis. I missed a couple of IETFs, so there might have been some conversations about this, but I was wondering how much thought was put into including or excluding other issues with 2330?
We put a fair amount of thought into it, and we decided that we wanted to do them one at a time.
Okay, because there's like single sections in 2330 that need to be wholesale replaced.
Yes.
Okay.
So send a draft. We'll put it on the agenda in Seoul. Or twist some arms to get the draft written.
Yeah. Okay.
Or send a list of sections that need to be fixed actually to the list, and see if you can find volunteers. Yeah.
So there was definitely one more
section numbers.
working item is this time issue. So the host times and so on. I had a draft on it. It expired. Yeah, I didn't have the time to update it.
Right.
So there will be some more work.
Yeah.
And finally, probably when we're done, we will
Pull them
refine
together. Yeah, that was the strategy, was that we fix them one at a time, and then we can roll a BIS from the fixes. So the time thing is basically you can unexpire that while we're waiting for 6-man to happen to do its stuff, right? Okay. So you volunteered for one by writing the draft in the first place, but actually a catalog of those, here's where it is and here's what direction it needs to go into to the list, and then we can solicit volunteers.
Hey, Delaney Elkins. I'm having a little bit of trouble waiting for 6-man. I mean, I wonder if we could figure out some weasel wordy way of saying, we're going to do this according to best practices defined in 2460 or 2460 BIS, or you know what I mean? Some kind of, just so that we can move it along here.
As soon as it is clear what will happen in the V6 ops and in the 6-man, we can go ahead.
I mean, people have been arguing about this for a while now. That's why I'm asked. That's what I'm saying.
On the other hand, having a draft that then conflicts with existing RFCs is worse than waiting. So that's my opinion.
Sure.
Yeah. It's fine for us to do the work up front if we're pretty sure it's going to happen, but then holding it in the working group is preferable to holding it post IESG evaluation, just for process reasons, because you don't want to have to then run it back through that process.
I guess this issue will be raised latest at the IESG.
Yeah, so if we send something out that was too weaselly, the IESG, if they were doing their job, would kick it right back to us. So we might as well keep it in holding pattern.
Is there a way of doing an explicit pre-review hold on another document?
Yeah, you can put you can make sure that there's if
you put a normative reference to a document
that
doesn't exist,
reference, it won't go through the RFC editor queue, but we can just stick a thing in the working group status for, should this take so long that both of us are replaced as chairs, that says don't touch this document until the 6-man people are done. But I tend to believe that 1 year thing, because the things that we're hung up on right now are relatively fundamental, and they'll have to make some choices at some point.
Marius, just a follow-up question. If there are more issues that are found, why not have a BIS of the RFC, not just IPv6 and
Well, so-
whatever else? And
So the idea is to have multiple documents and then roll them into a BIS when we've found them, because otherwise we've got this big open document
okay.
and, you know, it takes years to actually find people, because this is the unglamorous work of a standards organization. So it's hard to twist arms to get it done. And if it's a gigantic piece of unglamorous work, it's even harder to twist arms. Yeah.
Okay, I see. Thank you.
Good. Thank you. Okay. Then
So time format, if I understand Greg correctly, it's more or less ready for our last call, and you don't have any comments, correct?
So I have not yet finished sending out the model-based metrics last call email, but that'll go out probably during this presentation, and then the time format last call will go out shortly after that.
Okay, so next is alternate marking method for passive performance monitoring. To give it upside down. So.
Hi. Okay.
You had it upside down. But...
Oh, okay.
So go backwards.
Okay. Okay. This is an update. I'm Giuseppe Fioccola, and this is an update about the recently adopted alternate marking method for passive performance measurement. So we changed the name because the alt mark recall better how this method works, so alternate marking methodology. New authors will be added, be added because of merge between the framework draft and the alt mark draft. So just a short summary about this methodology for who does not know how it works. In general, we make a comparison between the use of OM packets against alternate marking. So the use of OM packets has some disadvantages because it does not work in case of auto order, does not work in case of ECMP because you have to insert the OM packets in the right place. So you need a powerful hardware. But all these advantages are qualities of alternate marking method, because the alternate marking method works in case of out of order and also in case of multi-point flows. In fact, the packet batch boundaries remain still valid, also in case of multi-point, but you have to put together the packet count at the multiple endpoints instead of OM packets that does not work in case of multi-point flow. The same strength of packet loss are for delay and jitter measurement. So we mentioned the average delay technique and double marking methodology for that kind of metric. So you have two marking, the first marking for packet loss and second marking to select one special packet to measure the delay. In this slide, we describe the document change between 0.0 version and 0.1 version. So important modification is the merge between the framework draft and the alt mark draft that we agreed with the working group chair in mailing list. So new section have been added, in particular some consideration about packet reordering, synchronization, and data correlation. And the new use case was mentioned about the overlay OM design team work, in which the marking method is a candidate for passive performance measurement. So there, I added the reference for the requirement draft and the gap analysis draft. So now I have a short description about the new section that have been added. Packet reordering. So you know that due to INCMP, packet reordering is very common in IP network. So how we have to choose the marking interval? If the marking interval is too small, packet with different market could be mixed for the wrong interval. So we cannot take the right counter. But if the marking interval is chosen in a proper way, packet with the different markers could happen just at the boundary, at the edge of our marking interval. So if we take the counter in the middle of our marking interval, the issue is solved. Synchronization. The alternate marking method is a relaxing method. I like to define in this way, and does not need a strong synchronization and strong time synchronization, because the change of marking is automatically a sort of synchronization signal along your network path. But we have to define a sort of synchronization between the network device, because each network device, and not to confuse the packet batch of the same market with the following packet batches. So the network device have to be synchronized to the same clock reference with an accuracy of L divided by 2, where L is the length of the measurement period. So in this way, you cannot confuse the packet batch of a marker with the following packet batch of the same marker. This is for packet loss. For one-way delay, you need that the two network devices have to be time synchronized. For the two-way delay, is the same for packet loss. So you can have a relaxing synchronization. Data correlation aspect. This draft is about the methodology, so cover just the methodology aspect. But we introduced just some consideration about how to correlate data. So we have some alternatives. You can use a centralized solution like an MS, a network management system, or define a protocol-based solution, a distributed solution by using a protocol or an existing protocol or a new one. So for example, you can extend 7374, 6374, T1.1 protocol, and so on. But a certain data correlation mechanism helps node or at the NMS to define the packet batch. So in this and to univocal and to define in an univocal way the packet batches. So for this purpose, we define the block number that could be calculated with the modulo of the local time and the marking interval period. So in this way, we define in a univocal way the packet batches for the data correlation aspect. This is the new use case that we added in this draft. The overlay OM design team that consider this method as candidate for passive performance measurement. But to make use of this marking method, we have to reserve 2 bits field in the overlay network encapsulation header. But as a definition for RFC 7799, this value does not affect the packet treatment over the network. So in this way, we can consider this methodology as passive. So we see that there is a working group, and also in NBO3 and SFC for passive performance measurement. Okay, this is another slide that highlight the sentence I mentioned before. So the section 3.4 and 3.5 or RFC 7799 give us the definition for active and passive. So the interpretation of the overlay OM design team is that there was also a discussion on the list. So a measurement method that should not modify the packet processing it could be considered as passive. Okay, this is all for the alt-mark draft. Just a few slides about the extension to active measurement protocol. So the previous draft is for passive method, but as we agreed in Buenos Aires, I renew this draft for active measurement protocol, and not only for, because the old one was focused on RFC 6812, so that is the Cisco SLA protocol. But now we want to implement an extension of T1.1 protocol. So this proposal defines a simplified mechanism with benefit to the metric precision and computational load. We have two endpoints, the sender and responder, that exchange two equal alternate marking data flows in both directions. And the goal is the measurement of packet loss, delay, and jitter. What are the benefits? So instead of timestamping test traffic, the test traffic is simply marked. And there are some key aspects of this mechanism. The improvement of metric precision, because the packet timestamp can be taken in a more efficient way. We don't need to put timestamp into the packet, and we don't need to put sequence number within the packet. And we can enable hybrid measurement. Also because in intermediate measure points, the traffic is marked, and in the intermediate measure points, the measure is managed in the same way as the passive performance measurement.
Okay, cool. So thanks. On the second draft, please read and comment on the list.
I'll finish.
I asked you for one slide.
Yeah, one slide.
That was three. Three is two more than one.
Okay.
And we have a question on the first draft from Ignacio, so I'll bring him in.
Hi, I would like to ask, because the statement about packet reordering is okay, it's good, but I expected some kind of rule to make this calculation about the number of packets that you are putting with one color and the other and the second color. In the same way that you do for synchronization part. I mean, this could be more clear when you want to perform this kind of measurements.
No, regarding the synchronization, I think that is enough, because if
no,
we choose
it's okay. It's okay about synchronization, okay? I'm just saying that for the reordering part, it could be good to have some kind of rule to estimate the number of packets that you are marking with one flag and the other flag, okay?
Yeah. But the issue is that the length of the marking interval depend of the network. You can choose the different marking interval but it depends by the network you want to monitor. So
yes, but
you very fast network, you can use a very low, very small marking interval. Otherwise, if you are measuring a very low network, you have to choose a bigger marking interval. So
yes, this is clear. I just asking to provide some kind of formula, you know. I mean, if you have the delays, you can provide some kind of formula, okay?
Yeah, I agree. The section is new, so comments are welcome. And thank you.
Okay, thank you.
Mike Ackerman, is this intended to work in both IPv4 as well as IPv6? And mainly on the first document?
Yeah.
That's the question.
Yeah, we are thinking about also IPv6, because now, okay, for IPv4 we cannot reserve no bit. For IPv6, I think there will be more chance to do it, and there is also the overlay OM.
So you're looking into how it would be implemented in both, it sounds like. Okay, thank you.
So are we on?
Okay.
Other questions on the working group draft P3M? So where do you think we are on this for working group last call? I think we have a November milestone for that. One more meeting cycle should be enough.
Yeah, we hope so.
Okay, good. All right, so we'll see you in Seoul then. And now we start with the lightning talks. So first is Reich Leibniz. And then you'll be the second one, I guess. So, go.
Okay, hello. My name is Reich Leibniz, working for Deutsche Telekom. Together with my colleague Rüdiger Geib, who also works for Deutsche Telekom, we wrote the draft Leibniz Spring PMS implementation report. And this report is about round-trip delay measurements. And we use the principle of segment routing. So we could steer a packet through a network with stacked labels. And we can see here that the packet is inserted into the network, and with the label stack, it travels through the network, and first label is 24, and the packet travels to the router with 24, and then next label is 25, and the packet travels to the router with 25, and so on and so on. And the packet stays in the forwarding plane. We only use management plane access to read out the labels from every single router, but the packet stays in forwarding plane. And we measured also the timestamps when the packet leave the PMS and when the packet received the PMS. By the way, the PMS is our MPLS path monitoring system, which is able to inject packets through the network. So we measured the timestamps, and the difference of the timestamps is our round trip delay. Okay, we can see here a little extract of our measurement topology, and we have Perfas Plus measurement agent, which is an Ippm conformant measurement agent. We have connected it to three routers, but the third is not shown on this figure. So we measured the round trip delay time from Perfas agent 1 to Perfas agent 3, and we compared that round trip delay time with those of this measured by the PMS. So the PMS measured the round trip delay time between PMS and label edge router 3. And we also measured the round trip delay time between those two label edge routers, which is today not possible with Perfas Plus, which always must be connected directly to the label edge router where we want to measure the round trip delay time. So we measured the round trip delay time in this way, that we measured over label edge router 1, 2, 3, back to label edge router 2, 1 and the PMS. And we subtract the round trip delay time from PMS to LAR2 from the other measured round trip delay time. And so we got the round trip delay time between those two label edge routers. And we also measured that round trip delay time in the other case between LAR2 and LAR3 over the LAR2 over the LAR3 to the LAR2 back to LAR3, LAR1 and the PMS, and subtract the round trip delay time from PMS to LAR3. Okay, we did the measurement in that way that we send every 10 seconds one packet out of our PMS, and 10 packets were, or 10 measurement values were calculated to one mean value, We measured 8 hours, so we have 288 values. And we did also the same with Perfas Plus and the PMS. So we have no congested links at the network and didn't have ECMP activated on our measured path. We used the Anderson-Darling key sample test to...
Okay, thank you very much. All in the room, please read the draft. Take comments to the list if you think it's interesting for IPPM. Next up is Greg Mirsky. 5 is 5.
Okay. Yes.
Which one? It's the Balamir one, right?
Whatever you give me.
No, REFL registered port. This is not we're not doing Trampolite. We're doing REFL registered port first.
Okay. No.
This one?
No. Yes.
Yeah. And then you have to hit the thing in order to make it show up, right?
No, it's the first slide for whatever reason.
Oh, okay, good. So, go.
Okay. There was a discussion we had in context of TWAMP data model, what port numbers can be used for the TWAMP test. And we agreed that this is a dynamic port ranges. But with experience of TWAMP reflector in large-scale deployments, we believe that there is a value of allocating port number for port receiver, which is a reflector port in TWAMP test. And that is based on experience with the mobile backhaul and in light of widespread deployment of things to things. So what is impact? Their port number can be advertised through the TWAMP control protocol, and then if their server does not support it, then it will propose back the port number out of the dynamic port range. And at the TWAMP test, there is no negative impact on ability to explore and measure various paths available through ECMP, because the source port number will be allocated still from the dynamic port range and can be variated in order to explore different paths. So the next steps is we invite your reviews, comments, and for expedite implementations and interpretation testing, might be considering the early allocation.
Cool. Has anyone read this one? Cool. Everyone who had their TWAMP hand up, please read it and take it to the list. Thank you very much. Do you want to try to start the NAT one then?
NAT one.
Yeah. So Muthu, you got the. So you now have 3 minutes, but go for it.
Yeah. Hi, this is Muthu from Ericsson. So our motivation for this work is that sooner or later there will be a need to obtain IP performance measurements across internet paths traversing NAT. And these could be, for example, measurements obtained with the providers towards consumer devices that may be behind NATs. So NATs can cause a whole lot of problem for application protocols that negotiate IP addresses and port numbers. This is not new to IETF. As a whole list of protocols that are broken by NAT. So OAMP and TWAMP, they negotiate the sender and receiver addresses and ports. So they are also broken by NAT when they have to obtain measurements across NATs. Next, okay. So this is just a pictorial representation of the problem. So there's a NAT between a test session, TWAM test session. The NAT translates addresses from one realm to another realm. Whereas the TWAM control is actually sending the sender address from the internal side of the NAT. So the other session reflector will send packets to the internal address in port, and the NAT would drop it. So this is one problem. It doesn't talk about any solution here. Right. So the scope of the work, if you want to bring to the discussion and document all the problems that NATs could cause for IPPM measurement protocols, even though it says measurements.
Let him finish.
Sure. Yeah, sure. So whether it says measurements, currently the scope is just limited to the measurement protocols, and put some requirements for possible solutions and any guidelines and best practices. We aren't thinking about any specific solutions at the moment, but just to document the problem and some requirements.
Thanks.
Yeah, Nalini Elkins, real quick. With IPv6 probably as the direction that some people think that we should be kind of heading into, I kind of wonder if we want to spend a huge amount of time with NAT. I just wonder.
Yeah, the question about whether NATs are relevant for IPv6, I think is a different problem, and there are some. I think there's a specification that talks about how to implement stateful NATs with IPv6. So I'm not sure whether NATs will go off with IPv6, but I think still the protocols are broken by NAT, so we'll have to document them and them somewhere.
Sorry, we can take this offline, but I just my actual point was that I think we don't want NAT.
Yes.
Yeah.
But NATs are there already.
Thank you for starting that conversation at the end of the IPPM session at IPTF 96 in Berlin. Thanks everybody for your time. Thanks to the presenters for the presentations. Thanks for the discussion, and we'll see you on the list and in Seoul. Have a good week. I will take care of these. I gotta run past there anyway. That's yours. That's not yours. That's good. My bag. That would have sucked.
I don't put my computer. Wait a second.
Wasn't me. I'm not optimistic about IPv6 getting rid of NAT. No. You can send me an email though. Like the next 3 days suck. Actually, the next 4 days suck. So, yeah, drop me a line. Please, when I say you have 2 drafts in this one draft, not a working on a draft, one's fine.
Where were you 2 years ago?